So, quick reminder, last class, we talked about if we are trying to find the volume, here, let me zoom in over here. We talked about if we're trying to find the volume that is created with cross sections of certain shapes. This was specifically cross sections of squares. So if I put all these squares in here and increase that to a super large number, we create basically this solid form, right? Where we can find, if we find the integral of the area, we end up getting what? If I integrate area, I get volume, right? Okay, and I'm integrating it from either with respect to x or with respect to y. So now today, instead of just talking about squares and rectangles, we're going to add on some semicircles and triangles. So this should be the notes already filled out from last class, but then we're just going to add to it. So a semicircle, what do I need for a semicircle if I'm trying to find the area?
Radius.
A radius, okay? So my r is my radius, and then our formula for area is 1/2 pi r squared, because it's a half circle. If it was a full circle, it would just be pi r squared. Okay, what two things do I need for a triangle?
The base and the height.
A base and a height. So B is my base, and H is my height. And your formula for a triangle, 1/2 base times height. Okay, quick thing to remember about triangles. If I have a right triangle, oops. What? Okay. Oh my gosh. Okay, that's fine. Oh my gosh, I'm trying to zoom in on it and it's not letting me. That's okay. Okay, if I have a right triangle here where this is 60 degrees, this is 30 degrees, and this is 90 degrees, right? Do you guys remember your special right triangle rules? Yep, 30, 60, 90. That means if this side is x, what would the long side be? X square root of 3. And then the hypotenuse would be 2x, right? And then if I had a 45, 45, 90 triangle, who remembers our special right triangle rules for 45, 45, 90? What would our legs both be? X, right? And then my hypotenuse would be? X times what? Square root of 2. The way I remember it is square root of 3 is with my 30 degrees. There's the only one with a 3 in it. And then I remember for my x root 2, I've got 2 x's. So that's what goes underneath the square root. Okay? So you'll need to remember that as well. And this technically, I could also think about if I draw an equilateral triangle, I could split that in half and I get 2 of those 30, 60, 90 triangles. Do you guys agree? So when we're finding area of triangles, we might need to think about using our special right triangle kind of stuff in order to figure out those missing pieces, okay? So triangles are definitely the trickiest part of the cross-section volume. All right, going on to the next page. This was from last class. Last class we found the cross-sections perpendicular to the x-axis was squares. Why didn't we finish this example? We finished example A and C, right? Okay, that was weird. I guess it just didn't write them down. We did not finish C? Oh, we didn't do C.
We did C on 2. Oh, wait. Wait.
What?
Oh, wait. Oh, I meant to be, okay, sorry. Example 1. I meant to do example 1 first. So let's do example B from part example 1, okay? So the cross-sections perpendicular to the x-axis are equilateral triangles. So what that means is instead of having this perpendicular shape be a rectangle, this perpendicular, think about putting an equilateral triangle on that red line there. Okay, so that equilateral triangle is coming up at your face or coming towards you, okay, away from the paper. Does that make sense? Can we visualize that? A little bit. So we're at this red line. We are putting our equilateral triangle up above this 2D graph, okay, making it a 3D shape. So I've got an equilateral triangle. We already talked previously about what the side length was going to be. The side length for that square was the square root of x minus x squared. So my side length for my equilateral triangle, if I draw my equilateral triangle in here, this side length down here is also the square root of x minus x squared. Do you guys agree with that? Whether it's a triangle, square, or semicircle, that's always the same distance, okay? So then that means if I want to find the height, well, let's think about drawing a 30, 60, 90 triangle. So this half on the bottom is just part of that whole base. So this is 1/2 of the entire quantity squared of x minus x squared. But then that means my height, because this is my base is the square root of x minus x squared. My height, this distance right here, is going to be all of this stuff, but then times what? Square root of 3. So my height is the square root of 3 times 1/2 square root of x minus x squared. And that's it. I've got a base, I've got a height. So now the next thing we have to do is we have to find the area of the shape that we're doing. Okay, so my area formula is 1/2 my base, which is the square root of x minus x squared, times my height, which is the square root of 3 times 1/2 times the square root of x minus x squared. Okay, are we all okay so far? All right, so now I'm gonna simplify this a little bit before we integrate it, so that way we hopefully don't make as silly mistakes. So I've got 1/2 times 3 times 1/2. I'm gonna pull all of those constants out in front. Okay, so this is now actually just, oh wait, if I pull out 1/2 times the square root of 3 times 1/2, I would get the square root of 3 over what? Square root of 3 over 4. Okay, and then if I multiply my square root of x minus x squared and my square root of x minus x squared, it does not just equal x minus x to the 4th. So I'm going to write it as the square root of x minus x squared squared. We'd have to FOIL that, right? It doesn't just become squared or become x minus x to the 4th.
I did that last time.
Okay, so now when I'm finding volume, volume is the integral, and then where are we integrating from? If I go back and look at this picture here, we're going from 0 to what? To 1. So 0 to 1. I'm just going to leave this square root of 3 over 4 out on the outside of it. And then I've got the square root of x minus x squared, and that's all squared. And if we take a quick pause and look back at what we did last class in example A, do you guys see this integral anywhere? From example A? Didn't we solve that already? So maybe we should just use this answer instead of trying to do it again?
Yes.
Yeah? So we're just going to replace that highlighted part there in yellow with the 0.129 that we got from last class. Okay, so our volume is just the square root of 3 over 4 times 0.129. Okay, and honestly, if you want to multiply this in your calculator, you can. If you want to leave your answer like this is also fine with me. Okay, so I'm just going to put units cubed. Now, if this was on a non-calculator portion of your test, the previous answer would have had to been done by hand, so you would have actually gotten a fraction, right? So you could have done the same thing. You have a fraction times a fraction. You could leave it like that, or you can multiply it out, whichever one you want, okay? Questions on that equilateral triangle piece? Okay, example C, instead of this cross-section being an equilateral triangle or a square, this cross-section, this line here in red, is now going to become a semicircle. Okay, so think about putting a half semicircle on top of that paper there at that point. And we are drawing a little picture to help us visualize this. Here's my semicircle. This base is still going to be the same distance as that triangle base, right? So this is equal to the square root of x minus x squared. But if I'm trying to find the area of a semicircle, what do I actually need? Radius. So my radius is 1/2 times the square root of x minus x squared. Now I can write my area formula. Area of a semicircle is 1/2 pi r squared. So put in my r value there. 1/2 times the square root of x minus x squared. And remember, that whole thing is squared. That's my radius. We're squaring it. Okay, do you see all the little places that we can make silly mistakes here? So we got to be really, really careful. Okay, so let's rewrite my area formula, but let's take out all the constants and then just leave my square root of x minus x squared there, squared in parentheses. So I can take out my 1/2, and then what is 1/2 squared going to give me? 1/4, right? So I'm bringing out actually a 1/8. Are we okay with that? Those highlighted pieces there? And then I'm just going to be left with my stuff in parentheses. So square root of x minus x squared. Squared. Don't accidentally drop that 2 there. Okay, you're squaring that whole thing. So I found the area. If I want to find the volume, well, volume is just equal to the integral of my area formula. So I'm going to put that 1/8 pi out in front, because it's just a constant. And then I'm going from 0 to 1 of my square root of x minus x squared dx. Now again, we came up with the same conclusion. This thing we've already integrated, right? What is that thing in yellow there equal to? 0.129. So I can go ahead and rewrite this as 1/8 pi, or pi over 8, times 0.129 units cubed. Okay, so let's see. What I'm hoping you're seeing is that this stuff is all based on this area or cross-section volume of a square, right? I'm multiplying this thing by the area of that square, the volume of that square. I'm multiplying this thing by, again, the volume of the square, right? So there is technically a shortcut where, as long as you find this square version first, there's a constant that you can multiply by to get those other values. I don't necessarily think it's a great idea to just memorize those things, because if you're trying to remember this for like the AP test and you don't remember how to find the exact formula, but you know how to find the area of a circle, right? Then you can find the volume by just integrating that, right? So I think it makes more sense step by step to like think through the process rather than just memorizing this formula. Does that make sense? Long term, you'll remember it more than just, oh, it's square root of 3 over 4. Yeah, I don't think you're going to remember that very far down the road, okay? But let's try out another example. Example 2 here. We were given 2 different lines and they intersected, but we did finish this one. I don't know why it like erased itself, right? What did we get for example A when we evaluated this? 2.67. Okay, perfect. And this was from 0 to 2, right? Okay. Perfect. Okay, so now we're going to do semicircles. Same thing. This black line here, that was where we put my square. Think about a square coming out on the paper. Semicircles are next. So this is going to still be my base, but I'm putting a semicircle on that line instead. So draw ourselves a little sketch of our semicircle. And my side length down here is 2 minus x. But for semicircles, I want what? Half of that, right? So my radius is 2 minus x divided by 2. Which means my area is 1/2 pi times my radius squared. Okay, let's simplify this out, pull out my constants. So I'm gonna have 1/2, and then I have another 1/2 squared. So if I pull that out, I'm ending with a 1/8, right? So this is equal to 1/8 pi times 2 minus x squared. Okay with that pulling out? Okay. So now my volume, we're integrating with the same domain, or sorry, same range of values there. So from 0 to 2. And actually, I'm going to put that number in front. So I'm going to put that pi over 8 in front of it. So I've got pi over 8. And then the integral of 0 to 2 times 2 minus x squared dx. And if you see again, we have this from above is equal to 2.667, right? So I can just replace this with 2.667. So then this equals pi over 8 times 2.667 units cubed. And then we did talk about example C last class, right?
Yeah, we can.
We got 6 for that one. Okay, wonderful. I don't know why it didn't show up. Okay, there we go. 6 units cubed for this one. All right, the last one on this example. The cross sections perpendicular to the x-axis are equilateral triangles. Okay, so again, on this black line right here, this is now an equilateral triangle that I'm placing on top of that. Okay, so I'm gonna draw my perpendicular, not my perpendicular, but my shape here of my triangle, where my base, my base is still 2 minus x. Okay, but if I want to find my height, well, my height is just, this piece right here is technically 1/2 of 2 minus x, right? So then what would my height be?
Square root of 3
Times the square root of 3, yeah. So this is my base. My height is the square root of 3 times 2 minus x divided by 2. So if I write my area formula out, I've got 1/2 my base, which is the 2 minus x, times my height, which is the square root of 3 times 2 minus x over 2. Now if I pull out all my constants, I've got 1/2, I've got a square root of 3, and I've got a 2 down there. So what constant can I pull out in front of all of this? Square root of 3 over 4. So this becomes the square root of 3 over 4 of just 2 minus x to the second power. We good so far? Okay, finding volume, again, same thing, we're on the same bounds, 0 to 2. So I'm going to integrate this function from 0 to 2. I'm going to put my constant out in front. And from above, we know exactly what this function equals. This integral of 0 to 2 of 2 minus x squared. That's equal to our 2.667. So if I multiply this, this becomes the square root of 3 over 4 times 2.667 units cubed. So again, still using that square answer, but timesing it by a different coefficient each time, okay? So example 3 says to find the volume of the solid in which the base is a circle centered at the origin with a radius 3 units whose cross sections are described. Okay, so right here I'm going to go ahead and draw a circle with a radius of 3. And it is centered at 0, 0. Okay, what is the formula for a circle?
X squared plus y squared equals r squared.
X squared plus y squared equals r squared.
In this case, r squared equals 9.
Yes, you are exactly right. Okay, so I've got x squared plus y squared equals 9. Okay, but that's only one curve, right? Technically, like that's like the whole thing. But when we've been talking about like when we're finding the area between or the distance between, we always take the top curve and we minus the bottom curve, right? Depending on if we're doing a vertical slice or a horizontal slice. So what do you think we're gonna have to do with this formula?
Divide by 2.
Not divide by 2, but what do I need to solve for?
One is the one variable.
Yeah, I need to solve for one of these variables, right? And if we're taking it with respect to x, I'm actually going to solve for y so that I have everything in terms of x, right? So if I solve for y here, I get 9 minus x squared. And then if I square root both sides, I have not just one answer, but two answers, right? Plus or minus the square root of 9 minus x squared. I don't want you to write down 3 minus x. Okay, the square root of 9 minus x squared is not 3 minus x. Okay? But what this does tell me is that this top part of the curve here, so this piece right here, that is my positive square root of 9 minus x squared. And this bottom part, that is my negative square root of 9 minus x squared. So now I have a top curve and I have a bottom curve that I can actually subtract from one another to figure out what this distance is right here, no matter where we are on the graph. Does that make sense? Okay. So I think the first one we're doing is a square, right? So we're doing perpendicular to the x-axis, and those are going to be squares. So I'm finding, if I cut this down vertically, this right here is going to be a square if I lay a square right on top of this and have it come out of the paper or come out of your iPad. Okay, that is my side length. So I need to find my side length first. So that's taking the positive square root of 9 minus x squared, and we're going to subtract my blue curve, which is actually negative square root of 9 minus x squared. Careful with those two negatives next to each other. Because now, what is my side length actually? Can I combine these?
Yes.
Yeah, just make this 2 times the square root of 9 minus x squared. So that's my side length of my square, which means my area of a square is this side length squared. So I'm going to have 2 square root of 9 minus x squared squared. Okay, so now let's talk volume really quick. When I'm talking about volume for this circle, there's 2 ways that I can do volume. I could integrate this from -3 to 3, right? And then of my stuff. Or could I use symmetry in this one? Yes, where it's going to be a little bit easier. You're not going to make as silly of a mistake because you're not putting in a negative value. So I would highly recommend going from 0 to +3 of our stuff with a 2 in front of it, okay? Because you're timesing this area on the right-hand side by 2, okay? But you don't have to do it that way if you don't want to. So, but that's how I'm going to show you guys. So we are going to integrate this for volume. 2 times the integral of 0 to 3. Oh, wait, pause. I forgot to simplify this one more step. 2 squared is what? 4. And then if I square a square root of 9 minus x squared, what am I left with? 9 minus x squared, right? Okay. So I'm still timesing this by 2. Okay, and then I'm going to bring my 4 outside here, but then I'm going to integrate from 0 to 3 of 9 minus x squared dx. Let's go ahead and evaluate this one by hand. So this is going to give me 8 times the integral of 9, that would be 9x, minus x, not squared, but x to the 3rd power divided by 3. And we're evaluating that at 3 and 0. The nice thing about 0 is when I plug that in, what am I going to get? 0, right? So we just got to correctly plug in 3. So if I correctly plug in 3, my volume is going to equal 8 times 27 minus, let's see, that's 27 over 3. So order of operations, parentheses first, this is going to be 27 minus 9. And 27 minus 9 is 18. So 8 times 18 is equal to 144. Okay, letter B says the cross sections perpendicular to the x-axis are semicircles. This is the 3rd semicircle one that we're going to do. So I'm going to help you set it up, and then I'm going to let you guys try it out on your own. So I'm going to draw my little picture here to help me visualize this. My side length down there, we already figured out, that's 2 times the square root of 9 minus x squared, right? So first thing you need to find is what is your radius. Then you got to figure out what is my area formula. And then you need to integrate it. Okay? We'll let you guys try this out, and then we'll go over it. Area 1/2 pi times the square root of 9 minus x squared squared. So that's really just 1/2 pi times 9 minus x squared. We good so far? Volume is just the integral from, we're going to double it, right? So it's going to be 2 times, I didn't give myself enough space there. I'm going to bring my constant out, so that's pi over 2 times the integral from 0 to 3 of 9 minus x squared dx. Whoa. And then those are going to cancel. So our volume is pi times our integral from 0 to 3 of 9 minus x squared dx. And if you look previously, that integral from that integral of 9 minus x squared, 0 to 3, actually we didn't evaluate that one just individually, did we? But it should be 18, right?
Yeah.
It's this piece?
Yeah.
So this is 18. So my answer is just what? 18 pi units cubed, right? Very good. All right, we'll do cross sections of equilaterals, and then we'll take a quick break before we finish this up. Okay, so instead of this line right here being a square or a semicircle, think about plopping an equilateral triangle on that line right there. Okay, so I'm going to go ahead and draw myself a picture of an equilateral triangle so I can label it, make sure I got all my pieces correct here. So that base on the bottom is going to be the same thing that our semicircle was, that our square was. So this is 2 times the square root of 9 minus x squared. And then that means if I looked at a right triangle, okay, this is technically just the square root of 9 minus x squared. And then what's my height going to equal here? What am I going to multiply that square root of 9 minus x squared by? Square root of what? 3. So my height is the square root of 3 times the square root of 9 minus x squared. My base is this 2 times the square root of 9 minus x squared. So now that I have those two things, I can plug them into my formula. Area is 1/2 base times height, so 1/2 2 square root of 9 minus x squared. And then times that by the square root of 3 times the square root of 9 minus x squared. And then let's simplify that a little bit before I try and integrate anything. So this 1/2 times 2, that goes away. So I'm left with the square root of 3 times.
3 squared is 9 minus x squared.
No, you're good. So then this would be the square root. Nope, I just said not the square root. So 9 minus x squared. Are we okay with that algebra simplifying there? Okay. So now I've got my area. I can go ahead and integrate this. So I'm integrating for my volume. And I'm going to have that square root of 3 out in front. What else do I also need out in front with that? A 2. Didn't give myself enough space there. So I need a 2 out in front. And we're integrating from 0 to 3 of my 9 minus x squared dx, which we already know what that equals. This piece right here equals 18. So I've got 2 square root of 3 times 18. So that just gives me 18 times 2, so 36 square root of 3 units cubed. So now, example D says the cross-section perpendicular to our x-axis is an isosceles right triangle whose hypotenuse resides along the base. What does that mean? So if I go back to this picture, this black line right here means that my hypotenuse is going to be on that line, and then I'm going to have my isosceles right triangle come out of the page. Okay? So if I were to draw a picture of that right triangle, this is my base, and then I've got my isosceles piece. Well, pretend those are equal to each other. Let's see if I can change it. No, not really. That's okay. Pretend this is isosceles where these are equal to each other. Okay? This is what is on the graph, and then the triangle comes outside of the paper. Okay? My hypotenuse down there is going to be our length of 2 times the square root of 9 minus x squared. And now to find my height, this is also this was a 90-degree angle, right? Which means that these would both be 45. So then if I think about drawing a smaller right triangle here to find my height, this would actually just be the square root of 9 minus x squared, right? Which means what would my height be here of that triangle? This would create a 90-degree angle, right? And then this is 45 degrees. So then this is also 45 degrees, right? So what does my height equal? Yeah. The 9 minus x squared, right? So this is my base. This is my height, okay, because these are both the same thing. It's also another isosceles triangle. And then I can go ahead and find my area. Before I do that, though, are we okay with how I got the base and the height there? Okay, so your area is 1/2 times your base, which is 2 square root of 9 minus x squared, times your height, which is the square root of 9 minus x squared. That 1/2 and that 2, that's going to go away. And then I'm just left with the area is equal to 9 minus x squared. Right? So now I got to find the volume. So volume is going to be equal to my integral from, what are we at again? 0 to 3, but we're going to multiply that by 2. Of my formula 9 minus x squared dx. And again, all of this stuff right here equals what? 18. So I can go ahead and just multiply. So my volume is 2 times 18, which is going to be 36 units cubed. Okay. Okay, again, the wordage on the letter E is a little tricky, but then once you figure out what your picture looks like, the rest of it is just like example D. So the cross-section perpendicular again to the x-axis is an isosceles right triangle again, but the leg is along the base. So I'm like taking this whole shape right here and I'm rotating it, but now my leg is going to be this value here of 2 times the square root of 9 minus x squared, okay? So if I were to redraw this, I'm going to kind of try and draw it to scale. We'll see how well that works. So my right triangle would look something like that, okay? Where this now is still 2 times the square root of 9 minus x squared, and this is a right triangle. Where these are congruent because it's an isosceles right triangle, right? So then what's my height? Also 2 times the square root of 9 minus x squared, right? Cool. So now my area is 1/2 base times height. So 1/2 2 times the square root of 9 minus x squared times 2 times the square root of 9 minus x squared. So that goes away, and I'm left with now 2 times 9 minus x squared. So then if I integrate that for volume, remember we're integrating from 0 to 3 of our function, 9 minus x squared. I've got that 2 in front, but then I also need another 2 because that is the symmetry, okay? So the first 2 right there in black, that's my symmetry. The other 2 is from my area formula. And I already know this is equal to 18. So then what is 4 times 18? What is it? 72, yes. 72 units cubed. So you can cross out A, you can cross out B. But we're given a region that's bounded by y equals natural log of x and y equals 2x minus 3, and we're supposed to find a volume with a, find volume of a solid width. And we're going to do semicircle cross sections perpendicular to the y-axis. We've done everything perpendicular to the x-axis this time, or so far. So instead of having everything in respect to x on my integral, it needs to be in terms of what? Y this time, okay? So if you guys would go ahead and graph on your calculator, y equals the natural log of x and y equals 2x minus 3, because we're going to need to be able to figure out where these things are intersecting. I'm going to go ahead and put a picture of what it should look like up on the TV as well. So when I am integrating this, well, let me backtrack. Let's first talk about the semicircle, okay? The semicircle's cross section's perpendicular to the y-axis. So that means I am cutting my shape horizontally to make my semicircles, okay? So that's where you're going to place the bottom of your semicircle, and then your semicircle is coming out of the page, okay? So you can think about it like this, even though that's, terrible 3D drawing. But you guys understand what's going on? Yeah? Okay. So I need to figure out what is that distance between that red curve there and that blue curve, okay? We'll call that my side length. Actually, I'm just going to draw a semicircle, and then we'll label it. So this is I need to figure out what this distance down here is. And in order to figure out what that distance is, I need to subtract my top curve minus my bottom curve. So when we're doing horizontal, you're looking at if I'm slicing towards the x-axis. So slicing towards the x-axis here, which one do I go through first?
Red.
The red one, right? So it's going to be my red curve minus my blue curve. However, if I take just my red curve, 2x minus 3, and subtract natural log of x, is that in terms of y? No. So what we got to do first is I need to solve both of these equations for x so that I have them in terms of y, okay? So for the first one, take e to the y, e to the natural log. That goes away. So our thing that we're going to actually plug in is x equals e to the y power. And then if I solve for x here, I get y plus 3 equals 2x. So that means x is equal to y plus 3 divided by 2. So again, we had to solve for x so that I can integrate with respect to y. So now when I'm finding the base of my semicircle, I'm taking the red curve minus the blue curve. So I'm going to have y plus, y plus 3 divided by 2. And then I'm going to subtract e to the y. That's the distance of that semicircle. Okay, but if I'm talking about a semicircle area, I actually care about what? What do I need to find? The radius. So the radius is 1/2 of this whole thing. Okay, so now when I'm integrating, actually first I need to find the area. Area is 1/2 pi times my radius squared. Don't lose all those parentheses and don't lose all those squareds. But then I say let's go ahead and take out my coefficients. My coefficients are 1/2 pi and then 1/2 squared. So what can I take out of all that? Pi over what? Pi over 8, yeah. So I've got area equals pi over 8. But then I still have all that stuff in parentheses. That's all squared still, right? We okay so far with that algebra? Okay. So now I have the area formula. I need to integrate that. So I'm integrating it from my y value number 1 to my y value number 2. We'll talk about what those are here in a second. But then I'm just going to put my pi over 8 out front. And then I've got y plus 3 over 2 minus e to the y squared. Okay, so I need to figure out what am I starting at and what am I going to. So I'm just going to label that A and B here. So now we can go and do what with my graph? What do I need to find? The intersection points, right? So I need to find out where does this cross at this point, and then where does this cross at this point right here. Okay, so go ahead and go second calculate, find at least one of them, and then I'm going to go ahead and write the answers up here of what those two intersection points should be. Okay, round to like at least maybe 4 decimal points before you plug it in. So now that we've got these x and y values for my stuff's intersecting at, technically my a value, I'm looking at y's, right? My a value is going to be this negative 2.889 because that's the lowest point that I start at if I'm doing my horizontal slices. And then my b value would be this 0.5831. Okay, so I'm going from my y-axis, or sorry, my y value of the negative 2.889 and going up to the y value of 0.5831. Okay, so if you plug those numbers into your integral, you will find that your volume is approximately 0.298 units cubed.
What?
Okay, go ahead and take a minute or two and plug in this entire function into your calculator with this being your a value, this being your b value, and see if you get that same answer. And if you are, you're good. You can go ahead and start your homework, and if not, ask me for help and I will check it for you to see what you messed up on.